Welcome to Algebra 2, Unit 3, Section 7, the quadratic formula. I can use the quadratic formula to solve quadratics. So the first thing we're going to look at is this little setup here, b squared minus 4ac. For the given values of these variables, let's go ahead and evaluate that. So we just take and plug in b is 7, so I would say 7 squared minus 4 times 2 times 5. And we can go ahead and 7 squared is 49 minus 4 times 2 is 8 times 5 is 40. So the value of this is 9. The next one is, again, b squared minus 4ac. So b is 3, so we're going to say 3 squared minus 4 times 1 times negative 3. And I end up with 9 minus 4 times 1 is 4 times negative 3 is positive 12. So this would be 9 plus 12. This is 21. So this brings us to our next piece of our puzzle, which is the actual quadratic formula. And this is a part of it. This section right here is a very important part of the quadratic formula. So b is equal to x is equal to negative b plus and minus the square root of b squared minus 4ac all over 2 times a. Okay, so as we said, this piece of the puzzle is very important because it relates to some of the things we've been talking about. But this has got a special name. This is called the determinant. Not the determinant, wrong term. Discriminant. Determinant something else. So that's called the discriminant, and what that does is determines whether an answer, right, is either real or imaginary. So either our answers are going to be real or imaginary is going to be determined by the discriminant in the quadratic formula. And what this does, the quadratic formula does tell us what the zero values of a quadratic is. It helps us solve it. So find the zeros of x squared plus 10x plus 2 by using the quadratic formula. Again, I always say a is 1 here, and b is equal to 10, and c is equal to 2. And if you need to, well, let's write it back here. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. So we're going to plug that in. Everything we have, a, b, and c, we're going to plug in to our quadratic formula. So negative 10 plus and minus the square root of 10 squared minus 4 times 1 times 2, and we're going to divide this by 2 times 1. So we're going to come over here and we have negative 10 plus and minus the square root of 10 squared is 100 minus 4ac, 4 times 1 times 2 is 8, and all over 2. So we get to this point and we are going to say that it is negative 10 plus or minus the square root of 100 minus 8 is 92 over 2. Now we're going to get into some deeper algebra here. And we're going to say negative 10 plus or minus. So the square root of 92 is not a perfect square. But a perfect square does go into the square root of 92. And so this would be equal to negative 10 plus or minus the square root of 4 times the square root of 23. And we're going to divide this by 2. So we know what the square root of 4 is, and that is 2. So now I can take and I can divide 2 into each of these evenly, right? So 2 goes into negative 10, negative 5 times, plus or minus the square root of 23, and this would be our answer. So x is either equal to negative 5 plus the square root of 23 or negative 5 minus the square root of 23, and we would leave our answer like that. And those are real numbers. They're ugly. They're not good to look at. They make everybody in the room uncomfortable, but they are definitely real number answers. All right, finding the quadratic again. So a equals 1, b equals 3, and c is equal to negative 7. Now the quadratic formula is really helpful when we are getting these crazy answers. There's easier methods of finding the x-intercepts of a parabola. So what we're going to do here is we're going to just plug in negative b, negative 3 plus or minus the square root of 3 squared minus 4 times a, which is 1, times c, which is negative 7, over 2 times a, which is 1. Right? Why did I write a? I don't know why. 2 times 1. So I've got negative 3 plus or minus the square root of 9 minus 4 times 1 is 4 times negative 7 is negative 28. So this is going to be 9 plus 28 over 2. So my answer here is negative 3 plus or minus 9 plus 28 is 37, the square root of 37, which is a prime number, all over 2. This would be our final answer. We can't simplify it any further, so we stop. Okay, and this would be negative 3 plus or minus the square root of 37. Here we have another one. A equals 1, b equals negative 8, c equals 10. So again, negative b, negative 8 plus or minus the square root of b, which is negative 8, squared minus 4 times 1 times 10, all over 2a, which is 2 times 1. So negative 8 is positive 8. 8 plus or minus, we just work through here, right? Negative 8 squared is 64. 4 times 1 is 4 times 10 is 40 minus 40 over 2. So we would further this up, and this would be 8 plus or minus the square root of 64 minus 40 is 24 over 2. Well, are there any perfect squares that go into 24? Yes, there are, 4. So this would be 8 plus or minus the square root of 4 times the square root of 24 over 2. So this is equal to 8 plus or minus 2 times the square root of 24. Oops, excuse me. Let's fix this problem right here before we get stupid. It's 6, right? This splits up. Square root of 24 becomes square root of 4 times the square root of 6. This is square root of 6 over 2. 2 goes into 8 4 times. 4 plus or minus. 2 goes into 2 once, the square root of 6. That's your answer. So it'd be 4 plus the square root of 6, 4 minus the square root of 6. Okay, now we're going to come up with some values that are a little bit tougher to work with, but we'll get them done, and we're going to have to expand our thinking. So again, now A is 2, B is negative 1, C is 2. So, negative B, negative 1, plus or minus the square root of negative 1 squared minus 4 times A, which is 2, times C, which is 2, over 2A, which is 2 times 2. So negative 1 becomes positive 1, plus or minus the square root. Negative 1 squared is 1, minus 4 times 2 is 2, or 4 times 2 is 8, times 2 is 16. 1 minus 16 over 4. So this becomes 1 plus or minus the square root of negative 15 over 4. So now we got a problem here because we can't have negative square root. We got to fix this. So this is going to be 1 plus or minus the square root of 15 times the square root of negative 1. And this is over 4. So this becomes 1 plus or minus the square root of 15 I over 4. So when we write complex numbers, we can't leave it in this form. So this would be 1/4 plus or minus the square root of 15 over 4I. And that's our answer. It is a complex number, right? I's always got to go in the back. Okay. And we have to make sure we put it there. All right, same situation again. A is 3. B is negative 1. C is 8. Okay, so let's plug it in. Negative B, negative 1, plus or minus the square root. It's always the same thing. B squared, negative 1 squared, minus 4 times 3 times 8 over 2 times A, which is 2 times 3. So negative 1 becomes positive 1, plus or minus, and then we're going to work this as 1. 4 times 3 is 12, times 8 is 96. 1 minus 96 over 6. Okay, so now we're going to take this, and this is going to be 1 plus or minus the square root of negative 95 over 6. I can't do anything with negative 95. There are no perfect squares that go in there. So I do have to fix it though. Got to get I out of there. So 1 plus or minus the square root of 95 times the square root of negative 1 all over 6. So this would be 1 plus or minus the square root of 95 over I, or times I, excuse me, over 6. So this is finalized up as 1 over 6, 1/6, plus or minus the square root of 95 divided by 6 times I. This is the proper form for the answer. All right, final one, right? Yes, no? Let's look down here. Nope. Okay. So, anyway, again, A equals 4, B equals 3, C equals 2. Negative B, negative 3, plus or minus the square root of 3 squared minus 4 times 4 times 2 all over 2a, which is 2 times 4. So we've got negative 3 plus or minus the square root of 9 minus 4 times 4 is 16 times 2 is 32 all over 8. So this is negative 3 plus or minus the square root of negative 23 over 8. Again, we got to get that negative out of there, so this is going to be negative 3 plus or minus the square root of 23 times the square root of negative 1 over 8. So our final answer, or we're getting there almost, negative 3 plus or minus the square root of 23 times I over 8. So our final answer is negative 3/8 plus or minus the square root of 23/8 I. So what does the discriminant do? Okay. It tells us the number and type of solutions it has. So if b squared minus 4ac is greater than 0, it has 2 real number solutions. And so your graph is going to look something like that. You're going to have 2 solutions. If it equals 0, you're going to have 1 real number solution. So what do you have here? You have a graph that comes down and it touches the x. Oh boy, that's just awful. I have such a hard time. So there we go. It just touches one point on that x-axis. Now, if it's less than 0 or negative, it has 0 solutions. Now, does this mean there's no parabola? No, it just means that the parabola does not touch the x-axis. It could look like this too. It could be down here. Those aren't touching the x-axis. They don't have any solutions. Okay. So one of the things they'll say is, hey, let's just look at the discriminant, right, and decide how many solutions. So again, A is equal to 1, B is equal to -6, C equals 7. So B squared, -6 squared minus 4 times 1 times 7. Well, this is equal to 36 minus 28, which is 6. So it's greater than 0, so we have two real number solutions. Oh, by the way, coming back up here, you have 0. Let me go back to this. Here, this is 0 real solutions, but you'll have two complex ones. Okay, two with imaginary numbers. So you'll have two complex values. Okay, over here we've got to get things cleaned up. We've got to get an a squared plus b squared plus c squared form. So I'm going to add 9 to each side. So I'm going to end up with x squared minus 6x plus 9 equals 0. It's got to always equal 0. So a is 1, b is -6, c equals 9. So b squared, -6 squared, minus 4 times a times c. So -6 squared is 36. 4 times 1 is 4 times 9 is 36. 36 minus 36 equals 0. So that's our discriminant is 0. Number of type of solutions, you have one real number solution. All right, get this one written in descending order, right? So I got x squared minus 6x plus 11 equals 0. So a equals 1, b equals -6, and c equals 11. Right? Let's move that over. Okay. So b squared minus 4ac, right? -6 squared minus 4 times a, which is 1, times c, which is 11. So I've got -6 squared is 36. Minus 4 times 1 is -4 times 11 is minus 44. That is equal to -8. Right? Discriminant, -8. So no real solutions. And this is probably the best answer. Just leave it as that. Either 2, 1, 0. No real solutions. So this would be x squared minus 4x plus 4 equals 0. A is equal to 1. B equals -4. C equals 4. So b squared, -4 squared, minus 4 times a times c, which is 4. -4 squared, that's 16. Minus 4 times 1, -4 times 4, minus 16 equals 0. Discriminant is 0. 1 real number, okay, solution. We've already got it in the proper form. Thank goodness. I'm kind of tired of doing that. So this is A is equal to 1, B equals -4, C equals 8. -4 squared minus 4 times 1 times 8, which is 16, minus 32, which is equal to -16. So -16 is the discriminant. 0 real numbers solutions. Right? No real number solutions. Over here we got to write this in descending order. It's not written properly, so we'll put it here. X squared minus 4x minus 2 equals 0. A is 1. B is equal to -4. C is equal to -2. So, -4 squared minus 4 times A, which is 1, times C, which is -2. And I get 16. 4 times 1 is 4 times -2. Or excuse me, -4 times 1 is -4. -4 times -2 is +8. That is 24. The discriminant's 24. You have 2 real number solutions. And that, I believe, yes, concludes our lesson for today. Peace.